I like to use percentages to introduce what we call algebraic thinking, which is really just a fancy way of saying variables and equations. Because variables and equations have a very important place in my mathematical problem-solving toolbox. And I can't ignore its value and importance. But I also don't want to just jump in because it is one of the topics that kids don't love, and I think it's again all about presentation. So me having knowledge about that beforehand allows me to adapt my presentation to whatever they would like. So we're in 15.3, section 15.3, where we're starting to talk about algebra and thinking along those lines. Yes, the next chapter's title is that, but it starts now really, where we just focus on percentages first and then open it up to something bigger. So my ultimate goal is to look at general problems and add this as a general problem-solving tool. So it sort of loops back nicely that there is another general problem-solving strategy, which is this one, that we point back to the beginning of the course. So let's do an example first that I may or may not have in the book, but I want to do it first, regardless. Let's suppose, what product do we want to buy? Pick your favorite product. Item of clothing, laptop, what do you want to buy?
Coffee.
Coffee? Coffee does go on sale, I guess, but it's so cheap anyway, so.
Cheese.
Cheese, all right, I like it. So cheese, whatever quantity you're interested in, is on sale. Let's say here, 20% off. 20% off all cheese. And specific cheese, let's say here, specific cheese or block of cheese that you're interested in now costs, what's a good price for a used block of cheese? They're not cheap. Huge.
Oh.
Yes. Thank you for embarrassing me. I do have an accent. Huge. What's the rough price so I don't embarrass myself even further?
$15.
15? Wow, what cheese are you buying? All right, fine. I don't know. I don't eat cheese, so I don't know. So that's the sale price. The question then is, what was the original price? Now, yes, this is still very simple. You can totally guess and check your way through this and find the answer. Because the numbers are nice, the percentage is nice. But what if I made this $14.99? Well, that's 99 anymore, right? $14.95. And I made that 17%. Now suddenly, to find the exact original price is not quite as simple to find it exactly anymore. So we use nice numbers, just because we don't want to mess with a calculator all the time. But this sets me up for fancier questions where guess and check will just not work. And I cannot rely on that intuitive side. I want to take a simple enough problem to understand, develop this problem-solving strategy, and then rely on that when things actually get complicated. So what we're going to do is say, I don't know what the answer is. I'm going to represent the answer, just like I did for the decimal fraction conversion. I'm going to represent my answer with question mark in a box. That's just a symbol. You can use any other symbol. You can use whatever you want to think of. You can make a little drawing, whatever you want. Let that represent the thing I'm looking for, which is the original amount. So there's a question sentence that usually happens at the end, with information being provided in the beginning. Question sentence tells me what I'm looking for. I'm simply calling it something else. Let question mark in a box represent the original price of that specific cheese. Now here's the issue that makes kids dislike this, or fear this, or yes, sometimes hate this, and therefore math in general. I want to essentially translate the information that's given through this, which here is in English, to my mathematical language. And in that sense, it very much is a language. That I'm translating this wordy version into a more concise sentence that we call a mathematical sentence. So now let's look back, and it says cheese is on sale, 20% off. The new price is $15. So that means an amount, the original amount was decreased by 20%, and now it gives me 15. This is the original amount. What is the calculation when I decrease it by, when I decrease the original by 20%? That's English. What am I doing mathematically?
Multiply by 22.
It's a decrease, remember? Not a percentage of a number. There are three calculations. So it'll be from 1 down by this 20%. So it'll be 0.8 or 0.80 if you want, because it's a decrease. So I go down from 1 by the decimal version of 20%. Multiply. What do I multiply by? The original amount, which is represented by question mark. Now I don't know, there's a number behind this question mark. I just can't see the number. There is a number. Just don't know what it is. So that question mark in a box behaves just like any other number. So this information in the sentences tell me that when I do this reduction, the sale price is $15. So we say equal 15. And we've translated the English sentence or sentences to our mathematical language, which turns out to be a more efficient language to work in when things, to solve technical problems. It's still a translation, just like any other translation. If you were doing a language course and you're given a couple of sentences or one sentence and asked to translate that, that would be a perfectly reasonable question to ask. We're doing the same thing. It is another language. That's all it is. This is a sentence. It has a verb, everything. Very similar properties to a language. So now I look at this. Now I'm in this mathematical language. I see I have a multiplication sentence. For now, we're not going to actually look at variables and equations. This is still our introduction, our crossover section. And I can convert this multiplication sentence into a division sentence with a question mark on the left. What is that division sentence? 15 divided by 0.8. Use your calculator, don't use your calculator. To simplify the right-hand side, what do I get? $18.75. Whenever we're solving a word problem, something that's presented in English, I translated it. I want to go back and present my answer in the original language, which was English. English. This was my choice for solving the problem. So I want to wrap it up in an English concluding sentence. which means I don't have any equations in that sentence. I don't have any symbols. I can have a number, sure, that's fine. I don't have any question marks or anything in my concluding sentence, where I simply say the original price was $18.75. It's a very good habit to get into, because if you look at little Timmy's work one day, it's just going to be numbers all over the place and it can't make sense of it. I want some structure so that everyone can read, this was my approach, this is my answer. So even if you don't understand the approach, you can still understand the answer. So for now, yes, we are dealing with something very simple, so it's a little bit of overkill, but when things get complicated, I really can't guess and check. And the numbers are too hard to really do anything else. And this is my backup method to get me to the answer. Any questions on any one of these steps? I really have 1, 2, 3, 4 steps. 4 steps. One is, let's give a name to the missing quantity that I'm looking for. Then translate the information into a mathematical equation. Look at that equation to figure out what that question mark in a box value is, and then conclude it with a sentence back in the original language. That will always be the 4 steps that we are going to use. The only thing that changes is the information in the problem. So now let's go look at our exercises. 15.8. And the only way to get better at these is to just do a whole bunch of them. And if you play it ahead, that's really all we're going to do. Is questions, 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 and more questions. Suppose you have a job. Your boss says, you remember when business was bad last year? I had to cut everyone's pay by 10%. Well, business is better, so I can raise your pay by 10% now. That will put you back to where you were before the cut. Is your boss correct? Now, some people have a very good intuition about these things. I am not one of those people. I use calculation to make sure 100% what is happening. Now, how am I going to make sense of it? They don't tell me. It's a different question, different information. But I can use a similar approach to try and make sense of it in my mathematical language. Now, I don't know what my original salary was. I don't know. So maybe we can call that question mark, so that I can have a number to work with. A number I can't see, but it's a number that is there. So let's say, question mark in a box, in this case, represents my original salary. Right? It's one option. And don't feel like, oh, I have to see exactly what to do before I can continue. If it turns out that this wasn't the most appropriate way to define my question mark, I can go back and do it again and adjust it. Maybe I need something else, who knows? It's just the first step. The thing with problem solving that frustrates people is they think I have to do it from the start and be done. It's very much a process that I go around and refine my system until I get the answer. Usually, we can do it in one go, but it's not expected. So now my boss says, no, my boss, your boss, I have to cut everyone's pay by 10%. So after the pay cut, really your salary, my salary, whatever, salary is calculated how? Different question, different looking answer or calculations but still based with that question mark. Still has that similar thing that I need a number that's there, but I don't know what it is. So I'm using this to represent that number so I can perform calculations with it. What is the calculation to answer that question? It's not silence, no. It's going to be a calculation.
You can multiply or subtract.
Just for the sake of consistency, we're working with percentages, it's going to be multiplication.
So multiply it by 100% minus 90%.
Yes, but remember, you're totally right. Everything you're saying is correct. But to get into a good habit, when I say things, like the question is, like you did, I say percentages. When I perform calculations, what do? Not a percentage. Decimal. So what is the decimal version of what you said? 0.9. Times my original salary. Now I don't know what the answer is because I don't know what my original salary was, but that would be how I calculate it. I'll put it in brackets, just to remember one thing, that if I knew what my original salary was, I could find it. Now my boss wants to give me a raise of 10% from this, right? So let's say here a 10% raise would now make my salary, not what in terms of a number because can't say the number, but I can say the calculation. What is the calculation? Well, it's whatever my salary was. What do I do with my salary to raise it 10%? 1.1. Is everyone happy with the 1.1? Okay, we have to be happy. If you're not happy, say so. I don't care about the detail in here now. That was my salary. That now gets increased by 10%. I'll put in the details, sure. The brackets was just there to reference the previous quantity. Yes?
Why is it 1.1?
Because so this is just a different phrasing. A 10% raise means I'm increasing that bracket quantity by 10%. Different ways of saying the same thing, right? And when I increase, my base is 100%, and I, let's say, add 10%. So that's 110%. But when I perform calculations, I look at the fraction version or, the decimal version, not the percent. The percentage is there for casually talking about it. This is now precise, so I just convert the 110 by dividing it by 100. And I like the decimal a little better than the fraction because I don't need to see all this. I can write it in a more compact way. So, the brackets here didn't actually matter. I can simplify this 1.1 times 0.9 times question mark. Because if you say 2 times 3 times 4, and you say 2 times 3, then times 4, is my answer different? No, it's the same. I can pair them up as I want to, right? It's the same. So that's all I'm doing here. I'm going to pair these up first, because they're numbers I can actually put together. Question mark, I don't know what it is. Who knows? I can put these together at least. And what would I get? 1.1 times 0.9. 0.99. And then, of course, I still have the question mark, and I can't go any further because I don't know the number that's hiding behind question mark. But I also don't need to, because that's not what the question requires in this case. How do I interpret 0.99 times my very original salary before the boss started fiddling with things? How do I now translate that information, that calculation, back to English so I can make a concluding sentence?
Both are equal, that means both are equal.
Sorry, I totally blanked out.
Like before the salary was equal, so equals to original salary.
This is the original, yes. If I multiply it by 0.99, what am I doing to the original salary? I'm decreasing the very original salary, salary, by how much?
0.01.
Now remember, I'm now speaking casually,
1%.
so it's percentage. 1%. So, not that you can tell your boss this, but you can tell your colleagues and talk about your boss behind your back, behind his back or her back. What would you say?
I quit.
1%? Whoa, that's a little extreme. Well, it's only 1%, but your boss is probably not the sharpest pencil in the bunch. In that I'm actually being cheated by 1%. And having the ability to do these things. How many people, if you ask them this question casually on the street, if you are on the street, or your friends, or whatever, how many, would you guess, I have no idea what the answer is, how many out of everyone that you ask this would say, yeah, that sounds good?
99.
99?
100%.
100%? No, I wouldn't say 100. There are some people that just intuitively feel, whoa, no, I don't know what the answer is, but that doesn't sound right. But I would say more than half, for sure. And having the ability gives you experience and helps your intuition to say, you know, no, that doesn't sound right. I might not be able to do it in my head, what's happening here, but give me a piece of paper, I can do it. I've had that firsthand. I can't remember the numbers exactly. I went to RBC to talk about TFSAs, and they said something that I knew, well, that does not sound right. And it wasn't right. I didn't, actually I did say something, but then I appeared to be the arrogant person saying something.
Was it for their benefit or your benefit?
I can't remember. It wasn't really anything that had any consequence, it's just something she said in the middle of everything else in terms of percentage, and it's like, no, that cannot be right. I don't know what the answer is in my head. That's not the answer. But you know, if I say something, well, oh no, now I'm the bad guy. But having at least some ability, or some knowledge, some experience, prevents you from being taken advantage of, if nothing else. I can't be without this, honestly. Anyway, 15.9. At least something. Even me, I say, no, I don't know what the answer is there. But I know something is not right. And it just comes with experience. The calculations take time. I'm not expected to do these in my head, but I have the method to figure it out. Where am I now? 15.9. A mayor notices these facts. The city budget last year was 25% more than the 15 million budget of the previous year. This year's budget is 12% more than the last year's budget. So this year's budget is 37% of the budget 2 years ago. Especially if you say that fast. Whew. Sure, whatever you say. And politicians have a way of doing that very successfully. But let's take our time and analyze this slowly. So I have a couple of years to keep track of here. I have last year, previous year, and this year. So previous is the first one. Last year, and this year. Is that right? Looks right. No comments? Okay. Now let's see what they're giving us. Just sort of a little diagram table, and then we'll make it a little more official. So I don't know. I know one, right? I know 15 million was the budget of the previous year. Okay? 15 million. The city budget last year was 25% more than 15 million. So if I'm going to go to this one, that is an increase of 25%. Please don't say plus. It's just, I know what you mean. Everyone knows what you mean. It's just, no. It just doesn't look nice. Use words. And when I'm ready for a calculation, I'll drop the percentage and the word. Don't mix them. It's not nice. This year's budget is 12% more than last year's budget. So this year's budget is an increase of 12%. So this year's budget is 37%. So the question is, if I skip last year and go from a percentage of the previous year to this year, what is the increase percentage? So step one, really, before I actually write down that first step, is understanding the question. If I don't understand the question, nothing is going to go well. If I start writing stuff down, that is just not going to go well. You'll see this with kids all the time. Somehow, somewhere, they get the message that if they have to read the question more than once, that shows weakness, and they shouldn't be doing that. If they read it once, they want to write down the answer. That's just not, it's not realistic. You can't expect that of yourself every time. Some questions are more difficult and complicated than others. So what are we going to do here? Well, it's actually pretty straightforward. I just need to find these numbers first before I can answer the actual question. So, it's not too much. I'll squeeze it in here. Should I? Sure. So last year's budget was, I guess, that's a simple increase of 25% on 15 million. I'm not going to write a million every time, just 15. What is the calculation? 1.25 times 15. We can write million there, I guess. So that is 1.25 times 15. 18.75 million dollars. So let's put that in. 18.75 million. Now I can do the same thing for another year. This year the budget is a 12% increase on the 18.75. So that'll be 1.12 times 18.75, which is 21 exactly? Oh, that's kind of nice. 21 million. Now I have the information to answer the question, and this question didn't necessarily at this stage require an unknown question mark to represent anything. That's okay. Sometimes I need it, sometimes I don't. And it's there if I need it. Now they're looking for the percentage increase. How much more? What is 21%? What is 21 million relative to 15? So it's relative to this. It's an increase from the 15. Now there are multiple ways you can do this. Let's go with percentage. Let's ask the question. Let's rephrase the question perhaps. The 21 million is what percentage of the 15 million? That's one question you could ask. What is the calculation to answer that? 21 divided by 15 made into a percentage. What do I get?
$130.
140%. Now I refer to my question. Just make sure I answer this question correctly. Well, it just says thoughts. That's not really a question. All right. So this is an increase of 40%, and not the 37 that the mayor thought it was. So perhaps the mayor had some ulterior motives by saying it's 37%. Look, our budget's not that big. Calm down, it's only 37. But actually, no, we're in the 40s now. And that's actually a big difference. 3% is a lot of money. Questions, thoughts, comments, criticisms? Compliments? No compliments? We only have a couple of weeks left. You're going to miss the opportunity to say what you really think, whether that is good or bad. And you're going to sit there and regret not saying more. But if you're in 143, then you'll have a lot of chances again. That was 15.9, 15.10. The only way to get better is to do more and more. Volume, quantity is going to help us because it allows us to see different words, different phrasings, and practice that translation. When you practice a language, it's just repetition, repetition, repetition. A company announced that it is increasing its workforce by 15%, which is 30 workers. How many workers will be in the workforce after the increase? That one's phrasing is a little bit more tricky, I guess. In that my preference to make a question, there's a lot of numbers missing, right? So question mark in a box feels necessary to me because trial and error is not an option for me. Can't depend on trial and error. But because there's a percentage increase and they don't give me the original amount, I need to keep track of the original amount because the calculation requires it. So let's say question mark in a box represents the original amount, or the original number of workers. So it doesn't really line up perfectly with what they're asking. They're asking for the end number of workers, right? So there is variation that I have to get used to. If they don't give me the original, I'm going to have that number to be able to take a percentage increase of that number. So now I need to translate the information to a mathematical sentence. Just like you would translate an English sentence to French or any other language you may speak. It's no different, really. So when I know it's going to be an equal sign. But it is based on the information they give me. I'm increasing by 15%, but they're only giving me the change. They're only giving me that increase amount. So I can rephrase the given sentence to say 15% of the original workforce is 30 workers. That would be the same meaning. So I have 15% of the original is 30 workers. We have to really understand what they're giving us, what they're saying, so we can translate it correctly, which is true for any language. So now I have a multiplication sentence that I can translate, that I can rewrite as a division sentence, which is going to be 30 divided by 0.15, sorry. And therefore the value of question mark is, whatever that is. Calculator says
200.
200 exactly? Oh, so nice. The numbers are so nice. I will help you out by saying in a test, if there is a word problem, which all of these are word problems, there is 1 mark reserved for your concluding sentence. So that I can try and force you to get into that habit. That's both good and bad news. But I see it as good news because it means regardless of the answer, you could have made many mistakes here. If you write your concluding sentence, you get 1 mark for the question.
Even if it's wrong.
Even if it is a horrible disaster, you get 1. Because I want to reward that good habit that people really struggle with. To really present your answer clearly to anyone that reads it. So, what now? Check the question. How many workers will be in the workforce after the increase? So I want to really answer that question. So after the increase, there are how many workers?
230.
230. 230 workers. Now keep in mind, you need to have a concluding sentence that doesn't have any calculations or question marks or anything. It's not just a sentence, it is an appropriate concluding sentence. Yes?
Doesn't the question say that or 30 workers, not saying that they start with 30 workers?
I know, every semester. Honestly, what happens, every semester someone says, you can interpret that different ways. And then I make a note, mental note to change it, then I forget, and next semester it's back. And then you say it again, and the cycle continues. You can read that different ways. The intention is that the 15% is the same, is equivalent to 30 workers. So if I say I'm increasing it by 15%, I'm increasing it by 30, those things are the same.
But isn't it saying like they're going to do either or, they're not going to do both?
I'm saying what the intention is. I agree that it can be misread and I need to change it,
Okay.
which I'll forget, and then next year you can see it again. The intention is that those two quantities are the same, which then allows me to write this. Otherwise, I don't really have enough information. I need to change it, yes. Will I? Probably not. No. I've done that with other things, and after a while, I would kind of miss it if it's not there, because every semester I look forward to that little typo. If it's not there, I don't have anything to say. So it crosses over. This one hasn't done that yet, but other mistakes crossed over to a permanent place in a book. Any other questions? But yes, if you encounter something like this in a test, you have to clarify. You have to understand exactly what they're telling me, or you don't have the chance necessarily to answer it correctly. And there is a chance it could have multiple meanings that I don't think of when I write it up. So you have to ask. There's time for more. Where are we now? 1511. 1511. But any typos you found in the book, let me know. This is only a first draft. It's full of typos. Full. But I think you got some. The town's budget is now $3 million. That is 25% more than it was last year. What was last year's budget? It's very straightforward. So I'm looking for the original. I'm going to say, let question mark in a box represent that original. the original, was it budget again? Budget. The original budget? Because if I'm going to take a percentage of something, if I'm going to increase something by a percentage, I need to have a representation of that original amount. If it's not given, then it's not given. The end amount is given. The percentage change is given. What was the original? So how do I translate the information to my mathematical equation sentence? Does anyone want to try?
Question mark times 1.25. Equals the 33 million.
3 million or just 3 for now? Everyone happy with that? I just put the decimal in front for consistency. Doesn't matter. If you have them flipped around, doesn't matter. So I have a mathematical sentence that is a multiplication sentence that I can rewrite to a division sentence as 3 divided by 1.25. And if you're not sure, take easy numbers. 2 times 3 equals 6. How can I shuffle those things around with a division instead of a multiplication? And my question mark value is therefore, what is 3 divided by 1.25? 2.4. Concluding sentence. Let me check. What are they asking? Am I answering that exactly? What was last year's budget? Last year's budget was 2.4 million. Once you get the hang of it, it's the same kind of steps, similar steps over and over, and that repetition creates confidence and security that if I just define my question mark, go through the motions, it's not really a mystery how did I get there. I can explain it very clearly how I got there. And I can teach that method much more effectively than guess and check or something intuitive. One more to end this chapter. 1512. Do we have time for 1512? Yes. One school had a decline in enrollment of 12% and now has 352 students. How many students did the school have before the decline? Very similar. Very similar. How can I define question mark in a box? Yes?
You could say let question mark in a box represent the original student count.
The original student count, or number. Perfect. That's exactly what they're asking for. And I need the original amount anyway, the original number. If I'm going to have a percentage of that, I'm going to need to represent that number. And they don't give it to me, in fact, they're asking for it. Then they say it's a decline of 12%, and now the student count is 352. So what is the mathematical sentence that translates that information? This is where you say stuff.
Question mark times 0.12 equals 352.
Thoughts? Yes.
Is that, 12%?
We have to read really carefully. Are they saying 12% of the original amount is 352? Or are they saying a decrease of 12% results in 352? I think it's the second one. So a decrease would mean I go from 1 down by 12%. So this would be
Oh, yeah.
0.88. Of course, she did that on purpose to test us. That's all. So then I have a multiplication sentence that I rewrite into a division sentence as 352 divided by 0.88, and I get a value for question mark in the box, which is what? 400 exactly. Man, these numbers are nice. And I check exactly what they're asking, so I can sort of use those words in my concluding sentence. How many students does the school have before the decline? And I can say, before the decline, there were 400 students. Once you get the hang of it, it's there to make it easy. That is the purpose of this method.